Welcome to SIM-PAC Live. I'm your host, Jeff Matthews, and today I've got a special guest with me, Aaron Grant from AZZO. Aaron is the Global Power Quality Solutions Manager for AZZO, and as you can guess by the title, he's an expert in power systems. And I want to talk to him about the outage in Spain and Portugal and a little bit of southern France. And one of the things we've seen since the outage is a huge amount of misinformation out there. Lots of people, shouting from the rooftops, and a whole lot of people coming to conclusions, and a whole lot of so-called experts. So I thought I would talk to one. Now, Aaron, as a way of introduction, I'm coming from this as a layperson, wanting to know a little bit more about our electrical systems, and because I've got an interest in decarbonisation, so same as a lot of people, but we don't have an interest in going and getting a degree in electrical engineering. So we're asking you to sort of translate and tell us a bit about what's actually happening in our modern systems. But before we do that, can I just go back and do a bit of revisionist history about how we got here, where we come from? Because we lose sight of that, and I don't think we should, is that for 135 years, the first power system was invented, and it revolved around, although I know you might argue it was a little bit of hydro, but it was really about burning coal, fossil fuels, heating water, and using an industrial age device, a steam valve, to be able to open and close that and spin turbines, and those turbines generating electricity with magnets. And then from a central point, and then we had essentially lots of light bulbs. And then over the next 100 odd years, we had more of these big things spinning, and the power stations got bigger. The average size in Europe, I think, was about a gigawatt for a thermal coal power, or a nuclear thermal or nuclear power station. And then we started to realise we needed to decarbonise, and solar and wind started to come in, and then they got cheaper and cheaper and cheaper, and to the point now, as you know, that we're driving full on towards renewable energy. But over the last period as well, we've had this massive electrification of everything. And so we're not just running light bulbs. And the modern demands on these grids, have the grids, first of all, have they kept up? And what do you see now? What are the lessons we can learn from Spain and Portugal?
Well, there's lots, and thanks for having me on the show again, Jeff. Really appreciate it. I think when you look back, we'll just go back to what you were saying about the changes in really how we've been generating electricity all these years. I mean, it really is amazing that we even have access to electricity when you think of it. So as much as we can look back where we are now, and I think there's this cognizance that is, we got to be careful that we don't look back at, whether it's how we generate electricity and shake our heads and go, I can't believe we did that, because there's a process to getting where we are. And to start off generating, like you can imagine, like Edison or Tesla starting off with IGBTs and nonlinear waveform. They're pretty clever what they did, but they're not going to be able to do that. So we had to start from somewhere, and we did it that way for a long time, as you said, for over 100 years. But really what's happened in that journey is the load types have also changed. So not only have we gone, well, we need to be more efficient, but we also want to try and decarbonize, so use less fossil fuels. And not even talking about hydroelectric at this point, just talking about obviously the fossil fuel aspect. So we want to clean up the planet. We want to be more efficient with our loads, so therefore we don't need as much of that generation as well. The reality is as well, when you actually couple it all up, we're going, our populations are dramatically increasing around the world. Our demand for electricity is also going up. I think a AI data center requires 10 times approximately the amount of power as a standard conventional data center. So you search for something on AI, Copilot, ChatGPT, whatever, the same search term as it is on a standard search platform takes 10 times the amount of power. So you add all these sort of things up, and we're going, all right, so we actually need more power, not less, but we're trying to be efficient. Now, with all those heavy efficient loads, I say heavy as in quantity, they're going to have a distorting effect rather, on the generation. And when that generation, like in Spain and Australia and many other countries around the world who are trying to do the right thing, becomes nonlinear generation, and what that means for your viewers is a means of creating electricity that is not through a conventional spinning motor that has inertia behind it, right? So we're talking about IGBTs, pulse width modulation. You picture what your phone, your computer right now is plugged into, right? That sort of technology is what is creating that power out there. And the risk of it is that when you have the generation is just less, like it's not as big. I mean, you picture a coal power plant, it's just big. It might be messy, but it takes a lot for that to fail. Now, that doesn't mean that we should keep all our coal power plants, not at all. But what it does mean is when we're replacing those things with a decentralized approach, and we're having all these DERs, we call them, distributed energy resources, and we're having them all plug into the same grid, like Spain, for example, and this is one of the learnings, they need to all be speaking together, because before it was one thing doing it, or multiple, coal power plants, let's say. But now you have different types of generation. You have a solar farm here, you have a wind farm there, you have, maybe you do have a coal power plant there. The list goes on, and they're all working together, or are they? And that's the point. Again, you've heard me use this analogy before, so forgive me, but it's the orchestra idea. And we use this term all the time in AZZO, and it's become a bit of a buzzword out there, orchestration of things. But it's like if you go into the Philharmonic Orchestra, amazing musicians, amazing instruments, take care of them really well, but you put earmuffs on everybody and you have no conductor. And you go in, you hear them, and you want to put earmuffs on yourself because it's horrible how it sounds. Now, does that mean that all those instruments are wrong and the players are bad? No. You just got to take their earmuffs off and get a conductor in there to get them all lining up. And once they do, it's literally music to your ears. And it's very interesting when you look at electrical, it's sine waves as well. That's all music is sine waves, different pitches, different angles, same thing. So that's why it's such a strong analogy. And what happened in Spain and what happens in many parts of the world, which is why Australia is so focused on generator compliance standards, is that everything wasn't talking in such a stringent, tight format where thou shalt be at this level with your frequency and phase angle and whatnot. It's not the same sort of standards, to my knowledge, that we have in Australia, for example. And so when there was oscillations in the system and other parts of the grid should support and then recover the oscillations, electrical oscillations, there is perhaps not the best communication that was occurring. And so therefore, instead of making it better, the situation made it worse. And that was only over the matter of about 5 seconds. Once it started to get to that cascading effect, it just blew out. It's no different than a trailer doing doglegging behind you. How do you fix it? But it got to the point of no return that it spun out of control. But it started way earlier in the morning. There was minor oscillations that it's kind of like you see that video that was out ages ago. I think it was the Golden Gate Bridge or whatever, where it was oscillating. Remember that? And it's due to wind coming through and it's spinning. And the point is that once it gets to a point, it can start, and then if the other events in the infrastructure don't stop that from happening, it can be the beginning of a flyaway model. And that's really seemingly what happened. There's lots of theories out there. They're still investigating it. But the reality is everything needs to speak together really well. And as we have more decentralized systems, it becomes more complex. And that communication and the speed and the accuracy becomes more and more important. But it can all be degraded by the power quality that is inherent in the system that comes from all the new types of loads that we have out there. So it's quite it's a big learning,
So let me go back and let's talk about inertia, these big spinning things, because advocates for, fossil fuels and not going to renewables and nuclear talk about inertia and things that are spinning. And the reason why they can cope with minor fluctuations, in power and absorb it is because it takes a lot of energy to accelerate and decelerate something that is big that's spinning. So that they're naturally built in this sort of FCAS market into it, there's a sort of frequency control. And without those big spinning things in the system, we need to have something else to deliver that frequency control. And you're talking batteries, because I've seen one criticism about Spain and Portugal that they don't have enough distributed batteries. And that was one of the reasons that when things started to go, that this oscillation, getting out of control. How do you get it back? How do you save it from tripping? That they didn't have enough batteries, and this is one question I had for you: are batteries a replacement for big spinning things? And should we have more of them? Is that the answer? Or
Look,
one of the bits?
Yeah, I mean, my personal opinion, not reflecting necessarily AZZO, is just mine. Like everything, there's a yes and a no, but there's always a consequence. And consequence, when I say consequence, you probably think negative. That's the natural way of saying, oh, there's a consequence to it. But consequences can be positive and they can also be negative. And it's just about accepting that they are there. And now how do we work with them? And it's really important that I say that, Jeff, because when you actually look at a lot of the solutions that have come out and are out, we probably don't pause and think, okay, hold on a second. We've had ballpark more technological advances in the past 100 years than we have in all of human history, right? So you said at the beginning, like electricity, the use of it in the common way that we use it, 130 years or so, right? So that means at the first certain percent of electrical journey, excluding what how the Greeks found electricity and all that with amber, actual usage, the majority of the time in recent memory or in recent time has been in the last 100 years. So how often, with the speed of the changes, started with the loads, so VSDs, LED lights, that sort of stuff. The loads have changed dramatically. The technology, I mean, you need a PhD to work on a car nowadays. It's the same thing, right? A 69 Mustang, you could be a mechanic. Now you need to be a PhD mechanic. Everything's gotten more complex. And so in the electrical system, it's the same thing. So when you just purely look at the load itself, have we stopped to go, what is the consequence of trying to be really energy efficient? LEDs, VSDs, as I said, simple ones. And I think that's where we've missed the mark a little bit, because we're so fast in going, well, it's reducing my energy usage. Yes, and fantastic, brilliant. But there's always a cost to everything. It's a consequence. Now, the consequence to putting in these efficient loads, and I'm getting to your question, these efficient loads is distortion. So it creates harmonics. Harmonics, always bad, never good, right? Just they're not good at all. That's why there's standards, and there's new standards coming out in Australia, all being well over the next little while. A lot of people hear the 519 or the 61,000 series standards, et cetera. They're designed to help to make sure that people keep the power quality or the harmonic injection less. But oftentimes it's ignored until things go boom. And that's why what you're going to see with the thing in Spain, the issue in Spain and Portugal and southern France, is you will see a big investment because there's major losses. People stuck on trams, production down, hospitals running on generators, elective or non-elective surgeries elective surgeries canceled. I mean, talk about disruption. I mean, I look at you and I, we're literally on our computers. Power goes down. I can't hail an Uber. I can't pay for groceries because I don't carry cash anymore. I mean, even if I did, would the register be able to open? Like, the list goes on. We are so assuming that electricity is always there until it's not. Then we do the 100-year thing. We panic and then quickly put a solution in and not necessarily assessing it. So When you then add in there the generation type, the battery question, it's important to answer the question in a clear way. So yes, I think batteries are a great solution, but it's always with the caveat, but let's understand the orchestration. How does the new load or the generation type, which is again a nonlinear generation, how does that then impact the nonlinear loads? How are they going to work together? Will they work together for 10 years or just 10 months? And that's where clarity on cause and effect needs to come in, and putting proper metering. I can't stress that enough. I'm talking power quality metering, Jeff, not metering. And I've heard people say, oh, I've got power quality metering. It picks up power factor and energy. That's not power quality. Power factor technically is not power factor because it's not a distortion of the sine wave. You need to actually get into the sine wave. And when you can see it, and that's what actually happened in Spain, there were some devices that picked up much earlier, around 8 o'clock, 9 o'clock in the morning, some variance. And the comment to that is, I remember one person, I think it's an executive, said, something doesn't look right. And I love that comment. He wasn't trying to be complicated. He wasn't trying to say, I know all the answers. He's going, it doesn't look right, Jeff.
Yeah.
Right? And that right there should make you think of your personal health. We were talking about organics before, going, I just don't feel right. What does that mean? I'm not a doctor. I'm not going to say, oh, it's because of this. It's just something's not right. Now, what do I do? Do I ignore it or do I go to the doctor? And now if they had started looking quickly enough and taken it seriously enough, maybe what happened wouldn't have occurred. I'm not saying it wouldn't have. I'm not going to blame, is it green? Is it a solar flares? Whatever. I'm leaving that to the engineers that are looking into it. But what I am saying is we can't ignore the symptoms, which is an indication of the problem. Now, unfortunately, if we ignore it, the symptoms get worse and worse. And the outage was the symptom, not the problem. So the question you asked is, is batteries the answer? I think batteries is an answer. But the part that we need to remember is that inertia is, the bigger the motor, the more the inertia, because it's moving. Batteries can synthesize it. You can have grid forming technology, etc. But yes, a spinning motor there's a reason why. If you have a sag, it's no different than if you're driving up to the set of lights. I remember when I was younger and you didn't have much money to put petrol in the car. I would coast to the lights, right? I'd see it coming. I'd turn the engine off and coast to save petrol. But I could coast. And nobody behind you.
Early form of recharging your battery.
Absolutely, yeah. And then you turn it back on, you started going. Now, you couldn't do that if there's no inertia. And that is the consequence of not having these big spin motors.
So I've got another question for you. Back in about 2016, I was doing some research for a speech I gave in Warsaw, Poland, actually, on the future of electricity. And I was looking at flywheels, and and flywheels are a solution of big spinning things. And I looked back then and thought, it sounds logical. I'm sure we're going to have those in the power system in the future. But it seems that to actually keep something spinning, there's no money in that. And, it's actually a cost to keep it spinning. So, we don't see flywheels in the system where, almost 10 years ago, I thought, well, that would be a logical thing to have in the power system. And also another sort of spinning thing is we're starting to see solar concentrators come in. And I know there's been a sort of a failure of one in the US, but we're starting to see them come in the Middle East for two reasons. One is that they can, and for people unfamiliar with it, they concentrate the solar to boil superheat water, and that water's kept steam, and that spins turbines and generates some power. But they're very close to getting 24/7 out of solar power with that method. But of course, you're ending up with this industrial age steam valve spinning a big turbine. Do you think that in a power system in the future, again, as we see roles for batteries, you see future roles for using renewable energy, like solar, to spin big things? Would that help with inertia and the grid?
I'll do a roundabout answer to that. So over the last, few years anyway, but certainly probably a couple of decades, there's a lot of high intensity just in the market. Like it's basically the one side and then the other kind of thing when it comes to renewables versus fossil fuels. I'm not saying there's no in between, but there needs to be a thinking side of going, look, there's benefits to both, there's downsides to both. That's the reality that we work with. And if we completely go, there's no room for fossil fuel or there's no room for green energy, it's too narrow to think that way, because there's benefits to both. Right? There's absolutely, but there's risks to both, which is what I was saying before about that we just need, like, it goes down to the human element. It's not my fault. But if I go in thinking I could be incorrect on something, or I could be contributing to destabilization, then I'm going to think twice about what I'm doing. So the answer to your question is, I think there's space for most types of power generation, if it's orchestrated in the correct way, because we need to learn from the value of the inertia that we've had for over 100 years, and we need to learn then also from the risks of having that inertia and how the prime movers are moved in terms of, is it from diesel, is it from petrol, what is it from water, and take all those learnings and come up with those results. And I do think that having a backup motor or spinning motor in some format is quite important to maintain that inertia when you're coasting to the lights inadvertently, because when it's there, it will provide that momentum forward. So if it's in the form of anything, a flywheel, for example, I think there's benefits to it. How that's implemented is a question. But when you go back to your comment before about there's no money in it, my point is always, and I say this to people with other areas in life, we go, look, spending money or saving money or making more money, what's the difference? In both worlds, your
one outage would pay for a flywheel.
right. Now yes. that's the point. Now, but to not fully answer your question, but to add a bit of I'll put a spoke in the wheel, to be pun intended. When you actually look at the what is in the load side, which is why I keep saying it, the loads themselves generate power quality issues, harmonics. That's what they do now because they're efficient. That flywheel will bear the brunt of that. Anything that's that's a power generation system will bear the brunt of it. So you look at the flywheel situation, you will have reduced efficiency, reduced lifespan. You will have vibration, mechanical stress. You'll have eddy currents in the bearings, overheating. And when all that's happening, unless people actually take seriously the electrical side of things, which I'll remind your listeners that electrical is the only trade that's based on a theory, right? So we always have to be students in this. Never stop asking questions and learning. I don't know everything. I might be classed as an expert, but I'm going, goodness gracious, the learning curve. You're always learning. And when you look at these things and you go, all right, historically I've gone, bearings just go. They go to heat, due to heat. It's like, but that's the symptom again. What's the problem? Are you sure you don't have harmonics? Oh yeah, we don't. How do you know? Well, we never have before. Well, your loads have changed. Do you have power quality metering? No. Let's have a look. And then all of a sudden you realize that flywheel that you've now listened to Jeff Matthews and you put in this great, expensive flywheel going, this is going to help us with the inertia. And he was right, let's say, but the harmonics was taking it down. Everybody's going to blame the flywheel as the problem. It's like, no, it's actually the interaction. It's the orchestra with the loads. So my point is there's no one solution in a silo. We've got to look at that culture change of going, everything has a consequence. No different than eating healthy has a consequence. It means you might not get that kick of endorphins when you have a chocolate bar. Yeah. But the positive consequence is you have a longer life, or you can do that marathon you want to do, whatever else it is. So everything, it's positive and negative. And if we look at other generation means, because a lot of times we say clean power, and I like to correct people to say it's clean generation. The power that's generated by nonlinear generation isn't clean. It's distorted right from the get-go.
Yeah.
And then when you interact with distorted loads, you have this cascade effect where you'll have resonance, which is the opera singer breaking the wine glass. You'll have overheating of cables, laminations, high vibrations, capacitors blowing in power factor correct units. So it's all about going the generation and the loads. How are they going to interact? And the good thing, like this is what we do at AZZO all the time, it's my job, is we put in brilliant meters, power quality meters, and we have portable ones that we've designed as well as permanent for OPEX versus CAPEX. And you just put that stethoscope on. Have a listen to the heart. How's it going?
Yeah.
You're a murmur. All right.
Because I read a comment online last night by a so-called expert. He said there's only two reasons a power system fails: is weather and human error. And what you're saying is, well, these things are really, that might have been in the olden days, but in a modern grid with modern loads and these distortions that can get into power system, is you can lose it. You can start fishtailing down the road, and things are going to get worse. And you've got to have, and there's, I'm assuming, lots of smart people and lots of smart computerizations to try and catch that and keep that grid stable with all of the demands that we've got, both load side and generation side. And one other thing about power quality and what you do, because this is something I've heard you speak about it, and I'd never really thought about it like that before, but what you do as an individual or business, let's say a business, is affecting what the harmonics and of the grid itself. So what you do in your factory or in your bit of load is affecting your next door neighbours, and that can affect the next door neighbours and next door neighbours, and so everyone has got a responsibility to actually, how is their load affecting the grid? Because at the moment, I think that people think, well, the utilities have got the role, we pay for the power, they should give us power and it should be of a certain quality. But in fact, what you're doing is affecting the quality of it, and also affecting the quality of the next door neighbours and the whole place. And that just explain that to viewers, how one person's load can be affecting the quality of power in the grid or in the network around that person.
In the electrical world, we oftentimes use water as a metaphor for electricity, right? Because it's visual. We can see electrons you can't see. I mean, I literally feel nauseous if I open up a panel and it's an old panel and within a few centimeters is live bus, right? Obviously we don't open up things live if we can absolutely help it, but because I go, that is scary how close that is to going bad, right? Now, I look at that because I know there's electrons that are going to do whatever it can to get back to the ground. It will go through me if it takes that, right? But it's also why, you have the 3-meter rule with being back because when the non-electrically minded person looks at it, they just see a piece of copper. They see nothing on it. So there's no risk. The risk is gone. And that's when accidents happen. So that's why we change it over to water. So if you picture water, now, anybody in the world, if they see an oil tanker go, everybody goes, that's horrible. Look at the environmental damage. Look at all that, right? Now, put it in a local term, right? Here in South Australia, and you definitely have beautiful rivers in New Zealand, and water is a limited resource nowadays in terms of clean water. So, how would your neighbors feel if you're all working on agricultural properties and you have all these pumps? If you saw your neighbor dumping a bunch of oil in the water upstream of where your pumps are, now you'd have an issue with that. Now, if it was just a tiny little cup of oil, you probably would go, well, that was dumb, but I'm not going to worry about it. Now, all of a sudden, all the neighbors upstream do the same thing. Now, you've got this oil slick that you're now pumping onto your trees that is risking everything. You're going to have an issue with that because you can see it. Now, one neighbor not putting a cup of oil in might not have the full impact, but if more of the neighbors get involved and pull it back, then all of a sudden you've got clean water again. And the fact is that it's not little cups of water, it's big bucket or of oil, it's big buckets of it going in. So when it comes to electricity, a lot of the times we think that it's the utility's fault if I've got a problem on site. The statistics are 80% of power quality issues come from you. It's no different than if I come into the office and I think I have no impact on my colleagues, and I come in angry every day, upset every day, ignoring everybody, rude. Oh no, I don't have an impact on anybody. I mean, nobody would ever think that. Of course you're going to have an impact. You know, just like if you're...
I work with somebody like that and I'm self-employed.
There you go. You got to work. You got to talk to that guy. And it's the same thing with smoking, right? It's why back in the day you could smoke anywhere. Now you can't smoke in bus shelters, whatever else, because you impact other people that aren't choosing to smoke. So when it comes to electricity, go ahead.
Okay, sorry, it's interrupting, but when somebody's got bad power quality, what are the symptoms they're seeing on their sites?
Yes.
I mean, I'm assuming it's blown generators or motors that are burning out every 6 months that are meant to have a 5-year life cycle or something. What are those symptoms?
Yeah, well, those, absolutely. Flickering lights. I mean, it's literally called, it's one of the power quality events is called flicker because it's based on flickering lights, which will have degradation on more than just the human brain when it comes to headaches. It'll have other impacts on infrastructure. High energy bills. A lot of times people just go, oh, it's cost of electricity going up. Is it? Are you sure of that? Because you will actually stress the transformer out. You have heat losses, et cetera. So it's going to drive your overall energy usage up. You're going to have failing windings in your motors, failing VSDs or VFDs, depending on how you say variable speed drives. You're going to have loud humming, laminations rattling together in your transformers, in your motors, whatever. You're going to have hot spots. You're going to have communications failures on your site because the neutral will get zero sequence harmonics that causes the neutral to basically almost catch fire. And oftentimes, because they're not protected by overcurrent devices, you will have major failures on neutrals. You could have earth voltage issues, have voltage instability, phase imbalances. I mean, Jeff, pick something. Like, it's insane.
So if anyone's seeing this stuff, and how many people do you see that have been ignoring stuff, like a motor burning out every 6 months? It should be lasting 5 or 10 years.
Constantly. And it's usually comes down to, it's not that these people aren't clever, right? Like, it's just that they're not aware. It's no different than, you know, we used to think that asbestos was the world's best building material. Or that germs, I think it wasn't until the 1830s that germs were recognized as being a real deal because you couldn't see it. So people thought it was witch doctor kind of stuff. Same thing with harmonics and power quality. You can't see it, but you can see the symptoms, but it's about identifying those symptoms. So like if I had a raw piece of chicken in my hand and shook your hand, you'd think I was mad.
Yeah.
But back in the day, there was no issues because there's no such thing as germs. So we're at that moment of being able to recognize there are germs in the system. Asbestos is bad for you. And it's about understanding that just because you have a mechanical symptom doesn't mean that's the problem. I can't stress it enough. You put in a permanent meter, ideally, because then you have context awareness rather than just a moment. But at worst case, you put in a portable for a couple of weeks. Power quality meter, we can provide all that stuff, no issues globally. You put that in and you just have a look. You've had, and I looked at a site I did in the Riverland. I can just quickly say this. In the Riverland, where they for 5 years would replace, would have to get rewound 2 of their 350 kilowatt motors every year. And they didn't know what it was. Got involved. And this is the culture thing. They took 2 years for them to actually recognize, or thereabouts, that it could be an electrical issue. 2 years. Got involved, put our portables on there, worked out that it was the pulse width modulation setting on the VSDs, as well as harmonics are being generated by those VSDs, which happens. So that's them almost puking in their own water, as it would. And then, I mean, it's a horrible analogy, but that's how we got to see power quality. then ingesting that and going, oh, it's all fine. It's like, no, we got to stop you from doing that. So we put in active harmonic filters, it's not our electric ones, AccuSigns, and insane. They've had, for the first time in 5 years, 0 failures, right?
Yes.
So You look
Yeah.
at that, and now they have budget to then modernize the site, add more stuff, because they're not just putting money into failures.
Yes. And they're also being good neighbours too, in terms
That's the point.
on the
Their
grid.
neighbors. Sorry, Jeff, you're getting me on a passionate moment here. Their neighbors are going, "Thank you." Now this side is going, "I'm glad you're saying thank you, but can you do something, please?" Because I can see what the neighbors are contributing.
Yeah.
And even though this site is much more stable, haven't had failures, they're still receiving some of that oil in the water. And they're going, "We don't want oil in our water. Thank you very much." So now
Yeah.
we're working with those neighbors. But again, it's trying to get their cultural mind shift to go, because they're going, "Well, no, they've improved it, so we don't have to do anything." It's like, no, mate, it's actually a joint group effort. All of us
Yes.
contribute. If you had all your neighbors chucking garbage on the road, you'd go, "Guys, like, we all got to work together, keep our neighborhood nice. Like, let's
Yeah.
work together." And that's what this is. It's a cultural shift. The technology's there. We just got to use it properly.
Yeah. Yeah. Okay, look, we're going to wrap this up, but before we go, Aaron Grant's, if you could wave a magic wand or give us your advice of what you think that we should be doing in Australia to future plan and so we don't have outages like they had in Spain and Portugal, what would you be doing?
I would really try to listen to what our sites and what the grid is saying to us. Something doesn't look right, then it's not. And it's about having that, again, to emphasize it, that cultural shift where we get rid of the mental blockers that it's business as usual. It's not. And I say that in an exciting way, because if we just go, what if I am part of the problem? What if all this new tech I'm putting in has a negative consequence? And not throw our hands up in the air and go, "We can't do anything," and go, and this is where the second thing is, we take that cultural shift and go, "Let me do something about it. I don't need to have a PhD, as you said at the very beginning. I don't need to be even an electrician or an engineer. I just need to know that I've got to put in some sort of listening devices that know what they're looking for in an engineered way, so they can look into the electron level virtually of what is going into my site and what's going out, and then engage the right people." Again, this is what we do for a living, what I do for a living, certainly. And we will look at, that's why we developed our EnergyX platform, is because it's all remote. We can look in, doesn't matter where you are. It's fantastic. And we can just go, "Hey, your health, really good. Proud of you. Go your hardest. You can put in a solar system, a solar PV system, whatever." But we'll also say, "But hold on before you do, because we see some signs that if you put that in, you'll further destabilize it. So let's fix your loads and then put that in." So it's culture shift. It's putting proper power quality metering in, and then listening and acting. Those are probably my 3 takeaway messages for literally the world on this.
Right. And we're running out of time here, but I know that what you do is often pays for itself. I mean, you fix your loads, you're going to get better, use electricity, have cheaper, have less things blow up, have less downtime in factories, etc. And so anyone wanting to know further about, how they could save themselves some money and get better power quality can get in touch with Aaron. Aaron, thank you very much. Great conversation. You're always entertaining to talk to, and thanks for coming on the show.
Thanks very much, Jeff. Appreciate your time, mate.